So as long as there are some correlation between these variables, their marginal contribution would be way different from the absolute contribution. The more correlation between these variables, the little marginal contribution of each variable. So again, here is 15 to 88, but it's 12 here. One other thing is, you see here is that difference is 12, almost 13 point, is not significant. But when you look at the t-test, you see we have a significant, highly significant. In other words, these two differences, this 15-point difference in systolic blood pressure between male and female is highly significant. Now, we can generate, or we can find this exact value using multiple regression. If you move the age out of regression, only run a regression as a systolic blood pressure as a dependent variable and sex as independent variable. And then we will see exact this number shows up. You will see. Here, if I click on Analyze, and then Regression and Linear, at this point, I'm going to remove that, actually remove the sex and put the sex back. Only have CC, I have systolic blood pressure as a dependent variable and sex as independent variable. All right. So this is a simple regression, one dependent, one independent variable, and that independent variable is a dummy variable. So, and it's fine as long as it's 0, 1, dummy variable is allowed in the regression. So I click OK. Again, I'm going to, this is for t-test we had. I'm going to get rid of, until I get to the coefficient. Okay, here. This is a regression, and this is a simple regression I was talking about. You see the dependent variable is systolic blood pressure, the independent variable is sex, and look at that coefficient. It's 15.288, exactly the same. The reason it's negative here because the computer in t-test wrote 139 minus 155, so that's why you get negative. But look at the absolute value, exactly the same. So again, if the dummy variable is only variable in your regression, the coefficient, the unstandardized coefficient on that regression for dummy variable is a difference in the mean of that outcome, whatever outcome you're looking for. Here is systolic blood pressure between the two groups. Here, the difference in mean systolic blood pressure between male and female is 15.288, and then represented by that is unstandardized coefficient of this dummy variable. Now, in practice, we rarely use that interaction term in the dummy variable. We use that interaction in order to show you how to find the two lines. But sometimes you don't need to do that. You want to find out how the groups are different based on that response variable. In other words, you want to see how the groups in this example, male and female, are different in terms of their blood pressure. And then you only use one dummy variable here because of gender. And then as you see, this is highly significant. And that t-value is exactly identical to that p-value here, you see. Exactly the same t-value. And then p-value, of course, the same. So again, these are a lot of similarity between the two t-test and the multiple regression, if only that independent variable is a dummy variable. So actually, instead of t-test, you can run a simple regression with your response and your group as an independent variable. Okay, that's conclude our lecture on dummy variable at this point.